course again, and in this video we'll be looking at the nitrogen cycle. The nitrogen cycle has to do with circulation of nitrogen between the nitrogen in the atmosphere and nitrogen in the earth crust. There is a continuous movement, circulation between nitrogen that is present in the air and those in the earth crust. So this topic seeks to evaluate and discuss this cycle between the two nitrogen. Actually, the nitrogen in the atmosphere is a free nitrogen. It's a gaseous nitrogen, uncombined state. But the one in the earth crust is in combined state. It's not free. You find it in protein, you find it in nitrate salts, you find it in compounds. But the one that is in the atmosphere occur in free state. So to study this movement, we call it the nitrogen cycle. Nitrogen is an essential element in protein formation in both plant and animal. But we cannot use the free nitrogen in that state except it has been converted into a combined form like nitrate. So there are processes that help us to convert nitrogen in the atmosphere to nitrate salt in our soil. Those processes are called nitrogen fixation. We want to fix nitrogen in the earth crust. That's fixation. So those processes that help us to convert the free nitrogen in the atmosphere to the one that the earth crust can use is called nitrogen fixation. How do we get nitrogen in the nitrate form? That is, in the one that is relevant to the earth crust. We can get nitrogen converted or fixed to the earth crust in the following processes. When there is thunderstorm or lightning, the nitrogen in the atmosphere can react with oxygen. Don't forget that the atmosphere, the air is majorly nitrogen and oxygen. So, and this element don't react because nitrogen isn't a very reactive element like that because of the strong nitrogen triple bond that is difficult to break. However, in the presence of lightning or thunderstorm, sufficient voltage will be produced to make nitrogen react with oxygen, and in that process nitrogen 2 oxide NO is formed. And this NO, we have been told in previous videos that it is a colorless gas that has strong affinity for oxygen, and when it reacts with oxygen it forms nitrogen 4 oxide, which is a reddish brown gas. As you can see on the screen, this is fumes of nitrogen 4 oxide. So this NO2, when it has been formed, this brown NO2, when it has been formed in the atmosphere and rain begins to fall, because the NO2 is an acid anhydride, it can dissolve in water to produce acid solution. So when rain is falling, it dissolves in the rain to give us trioxonitrate 5 acid, which is popularly known as the acid rain. So when the rain is now falling, it will fall into the earth as HNO3, and when it gets to the earth as that acid, what happens is that we have plants who through their roots can absorb nitrate salt. When the acid gets to the soil, it mixes with minerals and become nitrate salt. Then through that, the plant roots can absorb the nitrate salt to make protein that they normally produce. Then animal also can eat protein for their flesh formation, and the excess of that protein they are normally excreted as urea. Urine contains urea, feces also contain urea. All these are nitrogenous compound. Also, when plant and animal dies and decay, there are bacteria in the soil that help us to decompose this dead decay organic matter and convert them into organic nitrogen compound. This nitrogen compound are then converted into ammonia and ammonium salt by putrefying bacteria. You call them putrefying bacteria. Now, a portion of the ammonium salt can be converted to the useful triazonitrate 5 salt by nitrifying bacteria, while another portion in acidic medium can be converted back into gaseous nitrogen by denitrifying bacteria. Don't forget that putrefied bacteria will help us convert decay organic matter into organic nitrogen compound, and this compound will be changed into ammonium salt, which will be oxidized to a triazonitrate 5 salt by nitrifying bacteria, and can also be oxidized into free nitrogen if it is an acidic medium by denitrifying bacteria. Denitrify means nitrate removing bacteria. So this one will convert the ammonium salt into free nitrogen, and it goes back to the atmosphere. But the one that helps us to convert it into nitrate salt that the soil will need is the nitrifying bacteria, producing nitrogen relevant to the soil. So the nitrogen that was produced by the denitrified bacteria will eventually go back to the atmosphere and go and replace those ones that were lost by the virtue of thunderstorm that produce acid rain. Also, manure and fertilizers are normally added to the soil periodically to replace some lost nitrogen that have been used up by crops or plants. So this cycle operates in nature. It operates in nature such that the amount of nitrogen in the atmosphere remain constant at every point in time. So as the nitrogen in the atmosphere is being converted to nitrate salt, then the one in the soil also can be replaced back by those denitrifying bacteria. So this is this nitrogen cycle. God bless you.